Hi, this is Ahmed Liaquat, and this is my enhanced demo video for my Algo project. So my project was called Scrapex, which is a quick recipe fetcher. It is basically a web scraping project, and what I do is I scrape recipes regarding any topic. So the idea was to go to my front end page, type in any recipe you want, press enter, and the results, my program would go and fetch some go look at some websites and go look at some YouTube videos and pop the most relevant top three results on this dashboard. So in my previous presentation I explained Sir Umar Suleiman how this code got distributed. So the idea was I made a front end using HTML, CSS, JavaScript, and I connected it to the master node. The master node is basically acting as a server, and my front end sends post and get requests, and that's how it communicates using API through the master server. The master server, which is an orchestrator, it communicates with the rest of the servers. I named the rest of the servers as slaves because they basically have one purpose only. So they are not intelligent. They are just asked to do one specific task, and they go and do that task and send the result back to the master. The master then organizes how the data should be flown. So the three slaves that I have in my program are called Scraper slave, AI slave, and YouTube slave. Scraper slave is for static HTML websites. The master slave sends URL to Scraper. The Scraper then scrapes those URL, fetches the raw HTML, and then extracts the relevant data from it. It first goes down the DOM tree, and it basically get rid of irrelevant data such as the header, footer, the script, the styling of the page, and then using XPath, it looks at classes that might be useful, such as I would need to find the ingredients for the recipe. I need to find the procedure for the recipe. So it targets those specific classes and it extracts the relevant data from it. And then it sends back to the master. The master then sends it to the AI slave where I'm using Gemini API. What this does is it basically cleans the data further, and makes it beautiful and makes it concise using AI, and then sends it back to the master so it's more readable. The YouTube is a separate slave. It is used for fetching YouTube videos regarding a recipe. So the master sends the query to YouTube slave. The YouTube slave, using Google YouTube API, it fetches the top three YouTube videos and it sends back to the master. So this was how the distribution was working in my first presentation. The main uh, the main critique for it was that it was too slow. It was too linear and it was too slow. And it was basically defeating the purpose of making a quick recipe fetcher because it wasn't acting very quick. The the average time I was getting was somewhere around 90 seconds. Like here, I was searching biryani and it took 97 seconds to fetch these results for me. Three HTML websites and three YouTube videos. So it wasn't very fast. What I needed was parallelism. So that's what I focused for this enhanced demo. So firstly, let's discuss what the old flow was. The old flow was very sequential, very linear. At first, the master gets the top three URLs using Google Search API. Then it sends the first API to the scraper, waiting for the scraper to complete. And after the scraper completes, then sends it to the AI slave. The AI slave processes it, beautifies it, sends back. Then it sends the second URL. So it's very sequential and it waits for every single step. So that's what was pretty much taking up the whole time. It was very sequential. And after it has finished its its website task, it then goes to YouTube. It sends the YouTube slave the request and fetches top three videos. So it was very sequential, and it was the main factor that was driving the 90 seconds time. So this was made just to demonstrate the distributed programming, and parallelism was what was needed next. So now what's happening is the master slave now is using the built-in C++ async functions for asynchronous task, and it is using some other functions such as mutex to control the variables sharing between different threads, and it is preventing uh, the overlapping of variables as well. So basically, what I've done is I've just made the master slave be parallel. I haven't touched the other slaves. I have just made the master to be parallel. So now master dispatches multiple scraper tasks simultaneously. Now what happens is the Google API sends top three URLs. Now instead of sending the first URL and waiting for an answer, I make three different threads, and I send three URLs at the same time. And at the same time, I'm making another fourth thread, and sending a YouTube request to the YouTube slave. So four things are being sent concurrently. So what happens is that I don't have to wait for things to happen. The things are just in queue to be happen. So that's the essence of parallelism, and what I get is the time of 16 seconds as shown over here. And this 16 seconds is basically the shortest time for a single nee, the longest single process that has taken. So so if let's suppose the URL3 was taking the longest time, so the whole process is the time taken by URL3. Okay, so moving on, what's new in this version is that I have introduced parallelism using threads. So let's just give a quick demo. I'm going to start each and every server. I have basically four servers over here, three slaves and one master. What else is left? Okay. Now I'm going to start my, no, first let's organize these. So here's my AI slave, here's my scraper slave, here's my YouTube slave, and finally the master. The master is over here. The master is started on 8080 port, so I'm going to launch localhost 8080, and that's my front end over here. Now let's write a recipe. Let's say I want to get recipes for biryani. I press enter, and my server has started working. Now let's see how fast the results load up, and that's pretty fast at 97 seconds, which I was previously getting over here. And the same query, biryani, 97 seconds, and now it is even faster. It is 16.15 seconds, and it gets three HTML recipes, three YouTube videos. Yeah, so it is basically working, and the parallelism is I do need to work on formatting this in a better way. That's for even an enhanced version of it, basically just cleaning up the project. So now coming on, how have I achieved this? Now let's look at the logs for my demo real quick, and that would make the process a bit more clear. So let's focus on the master slave. The master slave, just like before, uses the Google Search API, and formats the query a little bit better, adds the recipe word to it, and minus YouTube, minus Pinterest, minus Amazon, just to filter out these websites so that it gets the recipes, not some other things other than recipes, and it gets the top three URLs from this API. Now what happens next is that I launch three connections at the same time. But what's different is I'm using different threads. Here I have stated the thread ID for each thread. Now at first I'm connecting to 8083, which I believe, yes, it is the YouTube slave port. So it is connecting to YouTube slave. Then it's connecting to 8084 three times. 8084 is my scraper slave. So I'm using different threads to connect to it, and I'll send three different URLs to it. Now next, what I do is, as I have previously stated, I send four queries at the same time. I send the YouTube query to YouTube. I send the HTML URLs to the scraper slave, and I'm not working in a sequential manner. I'm just sending it out. Whatever gets done first. No need of waiting. Just all of you go out there and do your job. Now on this slave end, it is not much different. It is the same thing. The main thing was I have changed the managerial process of this program. The slave acts just like before. It just accepts the first URL it gets, which is the serious eats, and yeah, it is the first URL. So it just gets the first URL. It extracts 28747 bytes. It cleans it to this much bytes, and it sends it back to the master slave. The YouTube also works in the same way. It just gets the query, it does its job, and it sends it back to the master slave. Now, coming on to the master slave, let's focus on my first thread. Okay, 32712, which expects this much bytes from the scraper slave, which is giving the first URL HTML back to master. It receives this. It uh, it then it then needs to connect to the AI slave, and it does over here. 8081 port, it is connecting to it, and it sends the HTML file to it. Now notice I haven't waited for its answer. I have just moved on to the next stuff. Now as soon as I have just finished with this, the next URL gets sent uh, to the to the scraper slave. So what happens is, as soon as I have got the results from the sorry, as soon as I've got it, the HTML data from the first URL, the second URL was just in queue. So as soon as the first URL got done over here, the next URL gets started loading, and it gets sent. So I'm not waiting for anything. It is just happening sequentially. So 32144 also works in the same way. It gets the URL, and it sends it to the AI slave, and then after that, the YouTube slave returns its answer. So I'm not wasting any time. Whatever gets sent first gets sent first. So before URL 3, the YouTube data sends its data. So why not just accept the data, and it processes it and stores it to send it to the front end. After that, the third URL gets processed in the same way, and it is sent to the AI slave. Now, lastly, no, sorry, this was my this was no, yeah, 15,000 was my last URL, so it was getting processed over here, and now I'm collecting all results. Now, lastly, I am using a data type called future, which is used in asynchronous functions for data that will get sent in future. You don't know what it is right now, but it might get sent in future. So now I have to collect all those results using future.get. I'll collect the YouTube results from YouTube, and I'll collect the relevant URLs using the future.get. Now here I am expecting 436 from AI data. Now I am expecting from this AI slave back to master, and I'm fetching those over here, the first thread over here, the second thread over here, and lastly the third thread over here. So now the last step was to get those data back. So so in essence, what was happening here was four requests were being sent at the same time, and whatever was getting done first was getting done first. And as soon as I was receiving those HTMLs, those were getting sent to the AI slave. No need to wait for the answers. Just uh, at the end, when the whole process is done, we can just get those data back and then be sent to the front end.